Okay, so here's a quick explanation of how the rolling ball down a ramp works. So, and you have three different possibilities. One is that the ball rotates faster than the ramp would like. So it's like, yeah, for example, it goes from here to here, but is one full rotation in normally speaking. That's in this scenario right here, but instead it rotates more than once. In this scenario here is normally, it's just rolling down normally, no slipping whatsoever. And this is the backspin case, when it's rotating backwards down the ramp, which is against what it would like to do. In this scenario right over here, at this instantaneous point here, it's rolling faster than what the system wants to. And look at the relative motion between these two different places here. You'll notice that this is moving backwards compared to the ramp, and therefore the force of friction always opposes the direction of relative motion. So in this case, it's pointing down like this. This is kinetic friction. In this scenario right over here, with the backspin, again, it's opposing the direction of relative motion. So in this scenario right here, there's an instantaneous velocity going this way. Therefore, kinetic friction is pointing backwards this way. Again, you can see the velocity is going this way and then it's going this way. In this scenario, though, it's slightly different. We have static friction, okay? And if you roll down the ramp like this, at this point instantaneously here, the net velocity between the two is 0. So there's actually no kinetic friction. But in this case, there is static friction. There's two ways you can think about this. The first is that there's a torque that's stopping it that has to get the ball rolling. If it were going the other direction, it would instead be going this way. This is something that'll be covered more in Unit 6. The other alternative way you can think about it is to imagine you zoom in very carefully to this system right here. The ramp is a jagged line like this, and the ball is a jagged line like this. This is exaggerated, but now you zoom in, right, and you look at one of these bumps. This is part of the ramp. This is part of the ball. And notice here that this ball will only ever hit this point as it's rolling down, this side. It'll never ever go back and hit this side. And so as it's rolling down, it bounces, it hits against this thing, and this gives you a tiny force backwards. And together, add all these forces together, you get a force of friction, okay? So this is a way to think about it anytime we have a situation where friction is involved, okay? I hope this helps.